Okay, so we're going to look at a little more animation, this time looking at how to use if statements to control color. So I want to have an animated scene where the color changes based on the location of the graphics object. And then I want to show how even motions that might seem different can oftentimes be captured in a method by the use of parameters. So we'll do the coding first without methods that capture that motion, and then we'll see if we can't, or we'll use methods, but then we'll notice where those methods have redundancy and see if we can't combine those methods into a single method by increasing the number of parameters or changing the parameters. Okay, so what I want to do is use our graphics to sort of create, let's have a window, maybe, I don't know, let's go 500 by 500. And I want to put a circle down here, a solid circle. And I want it to move up, but not erase. So it'll create a line going up. And then I want it to come down the diagonal over to there. So we'll go up and then down. I'm not drawing that quite right. And then have it come back up again. And I'll go down, and that creates like the letter N, it looks like. So that's the motion we want. And then, so where is it going to start here? It's going to start here at X being 0 and Y being, let's see, how big's the circle? So let's make the circle 50 by 50, so a radius of 25. So this will go down to 450. And this guy would start up here at 0, 0. And it would get down here to, let's see what that corner is. It's 450, 450. And then it would get back up here to 450, 0. And what I want to do is, as it travels up, somewhere here, say 300, and at 150, I want the color to change all the way across. So that's where we'll utilize the if statements. So let's jump over to Eclipse. I just wanted to get those values for the start and stop, and so we can figure out how many times we want our loop to run. So when I might have the loop run, makes sense to go maybe 45 times and have it shift by 10 each time, as it goes up and as it comes down the diagonal and as it goes up the other side. So I just am basing that on the 450 and then picking nice numbers. Divided by 10, you get 45. Okay, I also want to encourage you, if you haven't already, start making Java projects that coincide with the chapter that we're on. So this is a Java project for chapter 4. I keep mentioning this in the video, and then when I see someone doesn't have it, it's like, well, all your code's in one spot, and it's very hard to sort of tell what's going on later, especially if you have errors in that code. And then I'll just finish here, and we don't want, I think it's going to ask if I want a module. I don't want to create a module, just want chapter 4. But I'm going to be doing graphics, and so, well, let's make a new Java class first. Let's call it BigN. We're going to make a big N. And again, I want that class name to be capitalized, method names to be lowercase. In this source code folder, try saying that 10 times fast, we're going to need our drawing panel. So I'm going to copy it and just paste it down there, because I still want to keep it in 3G in case I want to run code there. This will work. Yep, there it is. So I'll keep it in both places, a copy of it in 3G and a copy of it in chapter 4. Okay, so we jump in here. Let's put a commenting at the top. This is another thing I noticed. You know, if you've been coding along with me, this is easy for you to do. You're not having to think about it. If you haven't been coding along with the videos, I can usually tell because your code's missing this header. So let's get them in there. It helps me figure out what's going on with you, and helps you look when you look back at stuff to know when it was, etc. The date, and then this class will draw a big N. Using loops or using methods and control structures. If statements. Change the color. Graphics object based on the location. That's really the point of this code is to look at how we're going to do that. But there's a lot of code around it, so it's good practice. Drawing panel. Call it panel. New drawing panel. I think I said 500 by 500. And then we'll need a graphics object. So graphics. Let's call it G. I'm going to pass this as a parameter. Let's call it graph. Equals. It's going to be a method of the panel. So panel dot get graphics. It's probably complaining because we didn't import. Yeah, we need to import java.aw. Let's just import everything from there. There we go. By the way, on the test, you don't need to worry about any import statements. Oh, I guess let's just erase what I just said. That's true when I said it, but it might not be true sometime in the future. So it will state whether you need to worry about an import statement or not. Okay. So going back to our picture real quickly, I mean, we can see this going up happens. Well, let's just code one. Let's code it first, and then we'll create a method after. So coding a method, I just need to place the first ball. So we're going to do graph dot. Oh, it doesn't make sense. Let's call a method here. Up, draw up. So we're going to call a method called draw up. And as parameters, we will send the panel, because we'll need to put it to sleep, and the graphics object for now. And those may change as I develop that method later. So draw up, public, static, void, draw up has a drawing panel. This is why I wanted to call it a panel as opposed to P, and a graphics object. I want to call that G. Okay, so in that, in this draw up, we need to draw the the initial circle. So it's g dot fill oval, and it's where? It's down at 0, 450, I think. Yep. 0, 450. It's 50 units wide, 50 units high, and let's just draw that, make sure it's in the right spot. Okay, there it is. It's clearly not green. So before well, let's go ahead and do g dot set color dot green. There it is. And let's just move it up. So to move it up, we're going to run a loop for integer I starting at 0, I going to 45. Increase I by 1. We're going to run our loop. Oh, that would be 46 times. I think that's right, though. And then, so what are we going to do here? We're actually going to put this code in that loop. We want it to go up. So the x value is not changing, but the y value is, and each time it's changing by 10. So we can go back to paper for a second. And I'm going to make a table here with I and y. And I'm going to think of y as equaling mi plus some y naught, like that. Okay, so then, you know, the m is the rate at which it's changing, or the slope, and the y naught is the initial value that we're starting at when I is 0. So that's actually what we're starting at, is when I is 0, and we know when I is 0, this is 450, and then when I is 1, this would be 425. No, we're not going by 20. We're not going by 25. We're going by 10. Sorry. So that would be 440. I just told you it can go by 10, but, and so when I is 45, you want this to be 0. So that m, the m is, the value of y is decreasing by 10 each time I increases by 1. So that's a negative 10, that's a positive 1. So the slope m is negative 10 over 1, or just negative 10. The y naught, or y0, is 450. So y is equal to negative 10 times I plus 450. And so when I come back into this loop, I'm just going to write that in here, negative 10 times I plus 450, and our circle is still 50-50, and we'll run it. And we should, oh, there it goes. It went a little fast, so let's put a sleep method in here. P.sleep, let's go, I don't know, 50 milliseconds. That's probably still going to go pretty fast. Oh, that's good. Okay, so now I want to change the color. So let's move this color into the loop. Actually, I'm going to call them, well, I kind of want to call a method to find the color. So let's do that. And let's do it by saying, let's not do it yet. Let's just copy that in there. And I want to have an integer variable y, and I want it to equal this -10 times I plus the 450. In other words, I want to replace this variable, this expression here, just with the variable y. And the reason I want to do that is so that I can then make an if statement. If, so let's see, if y, right now it's green, when we want to change it is when it's at 300. So when y is getting smaller. So if y is less than 300, g dot set color to color dot let's see, green, yellow, red. So yellow. And I could have an else statement here, else if y is less than 150, or I could just have another if statement. If y is less than 150, then g dot set color. So that's that new portion. So initially y will be green, and every time it goes into the loop, it'll be switched to green. Then each time y is less than 300, it'll switch to yellow, and then it'll fill the oval. Or once y, if it's less than 300, it'll switch to yellow. Then it switches to green. So I guess this has a little bit of extra code because, let's run it to show you that it works. Yellow and then red. So what's happening here, though, is that each time it comes in to the loop, it's setting the color to green. And then if y is less than, so let's say y is 10, the color gets set to green. Then y is less than 300, so then it gets set to yellow. But then that's less than 150, so then it gets set to red. So there's actually 3 color sets going on before it turns red. That feels a little bit redundant. I'm going to move this code down. It's not redundant code-wise, but if you were doing a lot of operations, this would take some time. We're not even seeing the time. One way to help eliminate that would be to go the other way. We could say if y is less than 150 here. No, that doesn't work. Okay, let's leave it. And we run it. So that's the up. And then I want it to come down the diagonal, which would be down this way. But then I want it to go up again. So if I'm going to have it go up again, it would sort of be the exact same code. Let's have it come down the diagonal next. Draw up, draw diagonal. Again, let's send the panel and the graph. And you can see right there that, I mean, the fact that these methods have the same parameters is sort of like, oh, there's some potential redundancy going on. And when we code this, you're going to see more of it. Public static void draw diagonal. Let's just copy this out. Actually, let's just copy all of this out. All of that out. And I'll explain why right now. So now what we want to have happen is the same color scheme, the same I values, but now both X and Y would be changing. Y actually needs to go the other direction. So Y would have to go back down, starting at 0 down to 400. And X is also going to have to go down from 0 to 400. So go back to paper here for a second. Again, I have an I, let's go I and either X or Y. And again, I'll have this be MI plus X naught. I think I should have done this before. When I is 0, this is 0. When I is 45, this is going to be 450. So again, this is going to go by tens. M, in this case, is going to equal a positive 10. And the x0 will equal 0. So x is equal to 10i plus 0, just to be consistent. But the exact same equation is going to work for y as well. Mi plus y0, but y is doing the exact same thing, 0, 0, 45, 450. So in a sense, I don't necessarily need x and y. I could have them be equal, but I think it's probably safer to keep the x and the y in case someone else comes along later and wants to figure out what we're doing. So, I could just put in here, adjust the y value, 10 times I plus 0, which is that. And then just put in here y, and then run it. And we'll see it go down the diagonal now, hopefully. Notice I didn't have to deal with the colors at all. It's going to do it itself. Oh, look at that. It's cool. So, I mean, that's fine. It's just, if you're going to do that, you might say something like, going down the diagonal, x equals y. So then that would be sufficient to have the person understand why you're calling y twice in this fill oval. But so notice, the only thing I changed in this method was that negative 10 to a positive 10 and that 0 to a y. I made 2 changes, and what that's saying is that this code is redundant. And again, I would need to go up again. I would have to have another draw up right now, and that third, that second draw up, I'm wondering if I should have this video be in 2 parts. Yeah, maybe I will. So that second draw up, we'll call it draw up 2. Draw up 2, again, panel and graph. And to do draw up 2, I'm literally just going to copy all of draw up. Make sure I put it below draw diagonal so that it's outside of that guy, and call this draw up 2. And then in draw up 2, y is changing the same way. What's affected in the second loop up is the x starting value and ending value is now 450. So that's this 0 here changes to 450. And when we run it, we have our big N with the 3 different colors. So that's cool. What I want to do is I want to stop this video and come back and try to eliminate some of this redundancy so that instead of drawing up, drawing diagonal, drawing up again, we can just have draw line, and it will, depending on the parameters, it'll draw what we need it to draw. Okay.